Please remember that the complete information for the class that you are about to view is at elithecomputerguy.com. Not only do we have our videos there, but we have part lists, diagrams, pictures, and even complete code examples. So if you are watching this video and you want more information, please go to elithecomputerguy.com. Welcome back. As you know, I am Eli the Computer Guy, and in today's class, we're going to be doing a brief overview of how to start programming in Python for your Raspberry Pi. So it is important to understand when you're dealing with a Raspberry Pi that this is a full-fledged computer with a CPU, with RAM, with storage, with a full network stack, the whole 9 yards, and so you can use multiple different programming languages to code for your Raspberry Pi. You could code in PHP, you could code in Node.js, just about any coding language that you would use for a normal PC or a normal server, you can use for a Raspberry Pi. But it is important to understand that kind of like the default standard for the Raspberry Pi as a programming language is Python. So if you're going to be interacting with the GPIO pins, those are the pins that allow you to get information in from sensors or send information out to other devices or to other things like servo motors. If you want to be able to interact with those types of things, Python is probably going to be the best way to go, at least to start with. So what we're going to be doing is I'm going to give you a brief introduction on how to start using Python on your Raspberry Pi today so that we can start getting into doing cooler projects going forward. So a big warning for today is don't be a dummy when you buy your dummies books. So I personally love dummies books. As somebody that's been in the technology field literally since 1996, dealt with everything from electronics to Active Directory to voice over IP systems, surveillance systems, Arduinos, Raspberry Pis, so on and so forth. One of the things that I really love about dummies books is for 20 bucks I can order one of these off of Amazon, get this on my doorstep the next day, and basically in an afternoon be able to read through and get a little better understanding of the particular technology that I'm dealing with. So with these Raspberry Pi projects that we're going to be doing going forward, one of the things that I thought is, hey, why don't I grab this Raspberry Pi projects for dummies books, and I can use this as a blueprint, or at least I can use this as a place to get some ideas for some of the projects that I will show you folks going forward. But one of the things that I wasn't thinking is that there have been two major Python versions, and those two major Python versions are not compatible with each other, or not very compatible with each other. So there was Python 2. Python 2 was very popular for a long time, and then the folks decided, hey, why don't we create a new version of Python? We're kind of going to build on a lot of the stuff that we had on Python 2, but we're going to reconfigure some things, so Python 3 is not backwards compatible to Python 2, and then we'll use Python 3 to go forward. And so one of the issues you run into whenever you're dealing with Python, you start looking at snippets of code, is one of the questions you have to ask is the snippet of code Python 2 or Python 3? Because if you start writing a whole bunch of code in Python 2, that is not going to be compatible if you're going to be using Python 3 on your Raspberry Pi or with your projects. And so when I went out and I got these dummies book, I was a dummy. I just wasn't thinking about it when I bought this book. And this book is entirely about Python version 2. So everything in here shows you how to do things in Python version 2, which is a problem because, again, going forward, everything should be for Python version 3. So one of the big warnings I will give you is if you're going to be going out there, you're going to be getting dummies books or any other kind of material to start learning about Python, do make sure you get Python version 3. You will still see a lot of material out in the real world for Python version 2. The reason is because Python version 2 was such a popular programming language that many legacy applications were built in Python 2. So there's still a lot of material out there for Python 2. But going forward, going into the future, everybody should be using Python version 3. So that's just one of those. Don't be a dummy. Don't be a dummy when you buy your dummies books. Make sure you get the dummy with Python version 3. Or you'll have a pretty yellow paperweight. The other thing that I'll say is, again, when I do these classes, I try to go down to the lowest common denominator. I try to make this as easy as possible for people to understand. So today and in many classes, we're going to be using an IDE called Thonny. So this is a Python IDE. It allows you to code in Python. I'll be honest with you, it's not a great IDE. It's not the prettiest IDE in the world, but It comes default standard with the Raspberry Pi, so it's already built into the Raspberry Pi. It is relatively easy to use, and frankly, it gets the job done. So to be clear, with this class or any other classes going forward, if I'm showing you something, you have an IDE that you prefer to use that IDE instead. Again, Python is a default standard. It's built into the Raspberry Pi. That's why I will be showing it to you, not necessarily because it's what I would definitely want to be going to if I was going to be building something for a production environment. So anyways, with that, let's go over to the Raspberry Pi. I will show you the Thonny, the IDE. I'll show you a few other things so you can start to feel comfortable about starting to code projects in Python on your Raspberry Pi. So here we are at my Raspberry Pi. The first thing that we need to do is just check on the version of Python that we're going to be using. Now, for the most part, the version of Python that you have probably will not matter, especially for the introductory classes when you're learning how to use GPIO pins and that type of thing. But it is important to understand once you start doing more advanced projects, the version of Python that you have running may affect how your project works and whether or not it will actually work. So the first thing that we're going to do is we're going to go up, we're going to click on the terminal, and we're going to see what version of Python we have. So the first thing we're going to do is we're simply going to type out Python space version, and we're going to see what version it is. And then this is going to be something that may throw you a bit for a loop. So again, as I've just talked about, we want to be coding for Python version 3. And so this is a brand new installation of the Raspberry Pi OS. And when I simply put in Python space hyphen version, we can see that this is Python version 2.7.16. Well, the important thing with Raspberry Pi to understand is from the default Raspberry Pi OS installation is you actually install both Python version 2 and Python version 3. So to see the version of Python 3 you're using is you simply type in Python 3 space hyphen version, and then here now we can see that for the version 3 we're using version 3.7.3. So if you simply type in Python space hyphen version and you see 2.7.16, you may think that you have to install version 3 when in reality you just do Python 3 space hyphen version, and then you will see what version of Python 3 that you're running. So that's just the first kind of thing. And again, if you're using the default standard, a relatively new Raspberry Pi OS installation, the version of Python that you're using should be fine. But that's how you go see these two things. So we're going to then close this out, and then we're going to go up here to the little Raspberry Pi, the little start menu type thing, click on this and go over to programming. So for programming, as default, they have Genie is installed and they have Thonny Python IDE. So Genie actually allows you to code for multiple different coding languages as an IDE for multiple languages. Thonny is only for Python. We're going to go for Thonny because again, when I took a look at Genie, there's a little bit more to Genie. It's a little bit more complicated. So when I'm teaching you folks how to do some of this basic Python work, I want to focus on just the Python, not the additional features of the IDE. So we will be using the Thonny Python IDE. So what we're going to do is we're going to simply click on this, and now it's going to open up. And so this is a little test that I was running before. So I just have a bob.py. So .py is the extension for a Python script. So such as .php is for PHP, .html or .html is for HTML web pages, .css is for cascading style sheets. In the Python world, it is .py. So basically what I've done here is I've simply written just a crappy little script. Here I'm creating a variable for Bob. Bob is going to equal 1. Sue is going to equal 2. Tim is going to equal Bob plus Sue. Then Sue, we're going to update the value for Sue. Sue is then going to equal Tim plus Bob. And then we're going to simply print Tim out. If you don't really understand this, again, go into the future. I'll explain more about how Python works for you. But this is just a very, 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 very basic little script here, just so I can give you an idea of how this works. So if I go up here, this is the run current script. So the script that I have here, that's up front. If I run this, we can then see that down here it spits out 3. So basically when we say print Tim, so Tim is Bob plus Sue, and so Bob equals 1, Sue equals 2, so Tim would then equal 3, Bob plus Sue, and that's what gets printed out here. One of the things, I have a window open here that shows us the variables. So it shows us the Bob variable has a value of 1. The Sue variable at the end has a value of 4 because of what we do here. And then the Tim variable has a value of 3. Now, one of the interesting things here is we can go through the debug process. So one of the things that we need to do is stop. So basically, whenever we run the script, we're also going to need to stop the script. So if we want to rerun it again. So this run current script, this simply runs the script without really the debug process. This here is the debug process. So basically where you can try to step through the code and understand what's going on with your code a little bit better. So if I click on this debug script, the first thing it's going to do is it's going to start with line 1. And then what I can do is I can use these little options here, step over, step into, or step out. So basically, as we get into more complicated scripts, these two little boxes on the side will matter more. But basically with the step over, this is how we can kind of step through this code. So we go from Bob equals 1, then it goes down to Sue equals 2. And what you'll notice here is the Bob variable now equals 1. Then we can step down here. We can see, so Tim equals Bob plus Sue. So we can now see Bob equals 1 and Sue equals 2. Then we step down one more time. Now we see over here, Tim equals 3. So Tim is Bob plus Sue. And then when we go down to the final thing where it prints out Tim, we can now see that Sue's value has been modified now up to 4. And so this is a way that you can try to step through the code, especially if you're dealing with variables. You're updating the values of variables by having this little variable window open on the side as you step through your code. It allows you to see how the different variables values get modified as you go through. So Sue right here is 2, and then as we go down, Sue now goes up to 4. So these are some of the things to be thinking about here. Basically, we can get out of this. If you want to hit the new button, so this creates a new pane for you if you want to do that, or if you want to be able to open a script. We're going to open a script here. I'm going to go to pirtest.py. So this is going to be something that we're going to be dealing with more. This looks more like what we're going to be dealing with the projects we'll be doing with Raspberry Pi. And this actually allows us to interact with those GPIO pins, like I was explaining to you. So basically with this, we have a PIR sensor and we have an LED. So we have the motion sensor connected to GPIO pin 4, and we have the LED connected to GPIO pin 16. And so basically what we have here is when the PIR sees motion, we're going to turn the LED on, and when the PIR sees no motion, we're going to turn the LED off, and then there's a pause for the code, and basically it's just going to continuously be redoing this. So it's looking for whether there is motion or whether there is not motion. Let me show you basically how I've created this project. So this is the very ugly build for this project, but it does what we needed to do. So basically here, this is where I have my PIR sensor. My PIR sensor is connected for the out down to GPIO pin 4, and then I have the LED, and the LED is being turned on by GPIO pin 16, and basically this is what I built out here. So the PIR sensor is connected to the GPIO pin, and the LED is connected to the GPIO pin. So when I run this script and the PIR sensor sees motion, then the LED will actually turn on and it will be green. So let's go back to actually take a look at the script again. I will run this and we'll do a little double pane thing and you'll see how this works. So here we have Thonny, it's open, we have this script open, and I have the project built out. Now the important thing to understand when you're dealing with the Raspberry Pi is that you actually have to run your Python script in order for your Python script to work. So you'll notice I'm waving my fingers in front of the PIR sensor right now, and absolutely nothing is happening with the LED. If your Python script is not running, then your script literally isn't running. So this isn't like the Arduino where you can simply upload the code to the Arduino, and as soon as you turn the Arduino on, it will automatically fire. This, you actually have to turn on the Python script. You can either turn it on from the terminal or you turn it on from Thonny or whatever IDE you're using. So obviously right now this isn't working. What I can do is I click on the run script. Now we can see that this is running down here, and we can see that the LED is now lighting up. So basically when it sees movement, it lights up green, And when it doesn't see movement, then it turns off. So it's very important to remember from a default troubleshooting standpoint is if you do not have the script on, so if I click this off here, right? So it's now off. And as you can see, it's now, I'm not running the script, and so nothing is happening. In order to actually make this all work, I have to run the script. And so I just click on the run button, and then now you can see that the LED turns on. So this is going to be a very important thing whenever you're dealing with Python scripts, especially when you're dealing with these GPIO pens. It's very easy to do something stupid and literally just not turn on your script, basically not run your script, and then you're going to be sitting there ripping your hair out trying to figure out, you know, what you screwed up with the variables when it's not the variables, it's just you forgot to turn on the script. So this is, again, this is just another example of what you can do with Python with your Raspberry Pi and a little bit of how this works. So now let's take a look at the debug process and the errors that you get if you fat finger something. So let's say for this PIR sensor, so PIR equals motion sensor 4, what happens if I forget a parentheses there? One of the nice things, if you forget to close the parentheses, you'll see this big gray box open up, and so you'll know, oh, okay. If you see something like that, that basically runs all the way to where you made the mistake of forgetting to close a parenthesis. So that's a useful thing there. On the other hand, let's say here, so we have the PIR.win motion equals LED on. So let's just say I forgot to put on, or maybe I put Maybe I put instead of on. That's the type of thing that can happen. And so one of the things I can do is if I hit the run current script, when I go to run this current script, it is going to give me an error here. So if I have this assistant open, so attribute error, LED object has no So basically what this does, it says, okay, on line 8, so I can go to line 8, and then I can read through. I don't really get any good highlighting or anything, but it does give me a little bit of something to work with. If I go down here, maybe I did off, I only did 1F instead of 2. We can like restart the script again. Again, when it goes through, it'll go PIR on line 9. So line 9 has no attribute of, right? You can go down here. You can also see it gives you a little bit of information down here so you can try to figure out what's going on. And basically you can go back here and you can say, oh, okay, so basically off. That's the problem that's going on. So that's a little bit of what you've got with the debug process. Again, it's not, to be honest with you, it's not a great debug process. It's not as pretty as some IDEs have, but it does give you something so that you can try to figure out what's going on. So as I can step through here, I get the attribute error LED object has no attribute. So again, if I go through the step through process, then it will highlight, and then I can try to figure out how to fix that particular problem. But to do so, I'd have to stop, then I have to do the on again, then I have to go back through the debug process, and then we can step through. So that's something that we've got with the debug process. One of the other nice things we have for just making sure what's going on with our code is within the options. I'll show you the tools in a few seconds, but basically I can highlight wherever a variable is used. So if I'm trying to figure out what's going on with the Tim variable, if I simply click on the Tim variable, this highlights every other time that Tim was used. If I'm trying to figure out what's going on with the Sue variable, I can click on Sue, and this highlights whenever else Sue was used. This also highlights whenever else Bob was used. So these are some of the kind of debugging tools that you have. Not great, not the greatest thing in the world, but you know, they do something for you. So past that, we can go over here to the files menu. So we have the file menu. This is the normal new, open, recent, you know, rename, that whole type of thing. Then we can go to the edit, you know, undo, redo, autocomplete. We have a whole bunch of things there. Then we can go to view. So view gives you a lot of options here. So it has the assistant. So this is the assistant over here that was basically showing us where the problems were. Events, exceptions, files. So if we want to have a little file manager here, we can have that to the side. Heap, help, notes. So notes is interesting. So basically, if you just need a place to write something, you can just write some notes there, or maybe use this as like a little clipboard. Basically, copy and paste something there. You can do that. Object inspector, outline. So if you're creating a larger project, you can show your outline. program tree, shell, stack, variables, so on and so forth. So you may want to just go through here and play with these different views, see what you actually want, see what you don't need, and go from there. Past that, you can come down here to run. So you can do select interpreter. And so again, so right now the details, so we're using the interpreter, the Python 3 interpreter here. So if for some reason you wanted to modify the interpreter that's being used, so the interpreter is what actually runs the Python 3 or the Python script when you hit the play button or the debug. So if you wanted to modify what that was, you can modify that there. I would argue, unless you really know what the hell you're doing, not to. Then debug current script. They have a couple of versions of the different ways to debug the script. I would just simply say debug current script nicer. Then we're going to go down. You can run current script in terminal. So if you just want to run this current script in the terminal, you can click on this, and then it'll open it up and it'll run in the terminal. So again, so basically this is printing out the value of Tim. So it's printing out the 3 right there, and then gives you the command line if that's what you want to do. If you go through here, it's got some other options that you may need in the future, but I probably wouldn't mess with right now. Past that, device doesn't matter at this point. Then we can go to tools. From tools, we have some interesting things here. So we have manage packages. So do remember, in the Python world, a lot of the functions that you're going to use come from packages. So basically you install a package into your Python environment, and then you can use functions and resources from that package. So an important one here is, if we go down, one package we're going to be using a lot is the GPIO0. So the GPIO0 is a package that comes with the Raspberry Pi operating system. So when we want to interact with those GPIO pins, this particular package is already here, but this shows us the packages that are currently built in to the Raspberry Pi OS. So if we want to add additional packages, we can simply plug something in here. And there actually is a package named Bob. If you click Bob, you can find the package. And if you want to install the Bob package, I'm not really sure what the hell the Bob package does, but if you want to install the Bob package, you would be able to do that. So this might be important. So again, if you're trying to build on somebody else's project, so you saw somebody else's project, you want to take it, you want to tweak it a little bit, turn it into your own. One of the problems you may have is that the package that you're looking for may not be here. So if you go over here, you look at this PIR test. So from the GPIO0 package, import motion sensor and LED. So that's coming from the GPIO0 package, and then from signal. So the signal package is actually built into Python, import pause. So if you had a few other things that you're importing, you may have the issue of you have not installed the particular package that you need. So that's something there. Open system shell if you wanted to. Then we can come down here to options. So options gives you a lot of different things you can play with. So allow only a single instance of Thonny. So if you wanted multiple windows of Thonny to be able to pop up, you may want to uncheck that. Log program usage, some information like that. The interpreter, again, I would not modify this unless you really know what the hell you're doing. The editor, so highlight matching names. So highlight local variables, highlight parentheses, highlight syntax elements, highlight current line. So this basically gives you some options. So when I was doing the highlighting the variables, I actually checked off these boxes here. So that's something that might be useful for you. Theme and fonts. So basically, you know what theme you're using, fonts, so on and so forth. Run and debug. So it gives you some information here if you want to modify how things are debugged. Terminal. Basically how you want to deal with the terminal. Shell, how you want to deal with the shell if you want to modify that. And then the assistant. So the assistant, that's this window that opens up over here. So what I have is basically open assistant automatically when program crashes with an exception, and open assistant automatically when it has warnings for your code. So basically, if this is unchecked, then you may have errors in your code, but that assistant window won't open up. So I've simply selected this. So even if it's closed, right? So let me just do this. So like if this is closed and I go here, and let's say I just get rid of that, right? And then I go to run the script. What we're going to see here is that the assistant automatically pops up, and it gives you a little bit more information about what the problem is with your particular Python code. So that's something that I think is actually pretty useful, you know, generally. So again, we can hit stop, and then if the code runs properly, you won't get that window opening up. So that only opens up if there's actually some issues with your code. And so that's a basic understanding. That's a basic overview of Thonny. I think it is useful to use an IDE like this to start coding in Python for the Raspberry Pi world. Again, is this the IDE that we will be using for bigger projects at the end of the day? Doubtful. Doubtful. But it's simple. Again, one of the things you have to be thinking about when you're learning is focus on what you actually want to learn, right? I want to teach you Python on the Raspberry Pi. I don't want to have to teach you an entire freaking IDE suite, right? So this way we can hyper focus just on Python on the Raspberry Pi, and then once you feel more comfortable with that, then we can use a better IDE. So this is just a little overview for you. Again, a big thing to remember is that if you're actually using the GPIO pins, right? If the code is not running, right? So if I have the code stopped, then the code won't run. Oops. Yeah, now it just locked up. Now it just locked up, right? So, okay, so we're gonna run the current script. So we run the current script. See, now the motion sensor actually works. I can see that being a problem with new people, where you go and you write the fancy code and then you simply forget to actually run the script, and then you're sitting there trying to figure out what the issue is, and the issue is simply that you don't have the script running. So that's just something to keep in mind. So there you go. Now you have a brief overview of the environment that we're going to be using, at least initially, in order to code Python scripts for our Raspberry Pi. Again, do remember that with the Raspberry Pi, you can use a lot of different programming languages, and those different programming languages can interact with the GPIO pins too, but the default standard basically for Raspberry Pi is Python, and so you know me, I like to standardize. If the standard is Python, we will start with Python and then go from there. Again, we will be using Thonny, not because it's the greatest IDE in the world, but it is a relatively simple, easy to understand IDE, so we can focus on the Python code itself. Then once you understand how the Python code works, you can use VS Code or whatever IDE that you prefer. Again, do remember that when you're dealing with code, it doesn't matter what IDE you develop the code in, right? Code is code. You can simply, so basically what I'm showing you, if you have an IDE that you prefer, you can use that IDE instead. You do not have to use Thonny if you don't want to use Thonny. Just kind of keep that in mind. One of the big things if you're going to be developing Python scripts for your Raspberry Pi is, do remember you should be coding in Python 3 now. 3, not Python 2, where this may run you into trouble. Again, if you're like me, and if you buy a little book on Amazon and you're not thinking about it, one of the issues that you may run into is that all the projects, in the book that you get may be coded in Python too. Now, to be clear, the code that you write will most likely run on your Raspberry Pi, but again, Python 2 is not the new standard. It is trying to be deprecated, and especially if you're learning, you might as well be learning on the new technology, the Python 3, instead of learning on Python 2 and then having to relearn things on Python 3. That's not necessarily a great way to go for your educational curriculum. So anyways, as always, I enjoyed doing this class. Look forward to seeing you in the next one. If you like the content that I create, please think about going to elithecomputerguy.com and becoming a member or donating. Please understand that all of the educational videos are in front of the paywall. That includes the videos, that includes the notes, the diagrams, and the code example. All of that is freely available and in front of the paywall. But if you want to watch opinion videos, or if you want to be able to comment, you do need to become a member. Membership is $5 a month or $60 a year and gives you access to those opinion videos and the ability to comment. If you don't want to become a member, you just want to give a one-time donation, there's also a donate button where you can do that. Please understand, in order to provide the education that I am, it does cost money. Servers cost money, equipment costs money, travel costs money. All of these things cost a reasonable amount of money, and the fact of the matter is YouTube's advertising program no longer supports creators the way that it used to. So if you want these classes to continue to stick around and you find them to be valuable, please think about either becoming a monthly member or donating a few dollars for this project.